Hi everyone, Ali Sadat here and welcome to Clockometer assembly video. In this tutorial, I will walk you through the PCB board assembly and integrating it into the main body of the Clockometer, helping you bringing your creation to life. Without further ado, let's make something amazing together. This is the electronic kit package of Clockometer, and it includes servo motors, ESP32 microcontroller, PCB board of Clockometer, USB power port, screws, and electronic components. For the complete assembly guide, navigate to Sadat Akhavi academy.com. Go to the product page. Here you can see some helpful link on the left hand side. Click on complete guide. This document includes every step that you need to take to completely assemble Clockometer. On the left hand side you can see different chapters of the document. The first page includes some helpful information about the document and some helpful links. Links to our website, social media, and other product related content. These are recommended tools: soldering iron, soldering wire, soldering iron tip cleaner, desoldering pump if needed, wire clipper, screwdrivers. Powered preferred. Here you can find more information about Clockometer and what type of skill sets it helps you to develop. Now let's get into the inventory of components and parts. These are the modules provided in the kit: ESP32 microcontroller unit or MCU, USB-C connector for power, 4 servo motors, 1 PCB board, 1 female to female wire, and screws. These are the electronic components provided in the kit: resistors, 2 types of capacitors, LEDs, connectors for microcontroller, and other type of connectors. This is the inventory of 3D printed parts. This section here is similar to 3D printing asset sheet file. You can find the document here. You can supply these to the 3D printing shop, and this document only includes information that shop needs to 3D print the parts for you. The complete guide document, it might overwhelm them. This 3D printing guide only includes the information that they need to print the parts for you. You can click on this link and you can click on this link and you can find all of the parts files here. Now let's move on to the first step of product assembly. For the first step, we have to upload the project code to ESP32 microcontroller. First, connect ESP32 microcontroller to your PC using a micro USB cable. Then we have to confirm your PC has the right driver to talk to ESP microcontroller. To do so, in your start menu, enter Device Manager and click Enter. Here, I have the driver installed and the PC has recognized my microcontroller. It uses Silicon Lab chip from CP210X series. It is port COM6. It might be a different port on your PC. To confirm this port is for our microcontroller, let's disconnect and reconnect the microcontroller. As soon as you disconnect it, it goes away. And when you connect it again, see the section ports, COM and LTP ports just came back. For the cases that you don't have the drivers installed, the device gonna come up under other devices. This is the point that we need to download the driver from Silicon Lab and install it. And this is what the process is. This driver is for this chip, and its driver could be downloaded from this link. So let's assume we need to install this driver and see what the process is. Click on the link, go to Downloads tab, download the driver for your operating system, and click Save. You just need to extract the content and you don't need to execute anything. Go back to Device Manager. If you don't have the driver installed, your device will not be under ports. You just have to go under unknown subfolder and the process is going to be the same. Just right click on the device, click Update Driver, browse My Computer and Files, navigate to the folder that you just extracted and just click Next. It's gonna scan the folder and install the best driver. You can confirm this by going back to Device Manager and your device should come up under Folder. Now, let's move on to the next section, installing Arduino IDE. This is an IDE or a graphical tool that's being commonly used by professionals and hobbyists to develop code and upload their code to microcontrollers. Navigate to this link, download the right software for your operating system and click on it and follow the process to install the software. We need to install few libraries in the IDE. What these libraries do, they help IDE to understand the code and upload the code appropriately to the ESP32 microcontroller. Just on your IDE, navigate to Sketch, include libraries, manage libraries. Search for ESP32 servo and install the library by John K. Bennett and Kevin Harrington. Now for the next step, we are going to download the Clockometer code. Just visit the product page and click on the software and firmware link on the left hand side. Click on download source code zip. Click on save. Extract the files. And when you click and navigate to Arduino IDE folder and double click on Arduino IDE.ini file. This is the main file of the project that it calls other libraries and functions to perform their tasks. Here you can see the steps that you have to take that I just shown you before. Now let's update the code based on your environment configuration. Clockometer needs to access the internet. Clockometer uses atomic time servers on the internet called NTP servers. And to access those, it needs your Wi-Fi details to log into your Wi-Fi to access the internet. To supply Wi-Fi credential, you have to go to setting and struct.hpp file as shown here in your IDE, and just you have to supply your Wi-Fi name or SSID and password. Please note these information are case sensitive. You have to provide your Wi-Fi SSID or Wi-Fi name here and password here. As mentioned before, these are case sensitive details. The next step is to configure time zone setting of your clockometer. The time provided by NTP servers are based on UTC, Universal Reference Time. One way to know what your time zone is, just ask Google and it shares with you what the offset of your time zone is. For example, I'm based in Melbourne, Australia, and time offset based on hours is 10 UTC. It is plus 10 hours UTC. And this is the formula. Plus 10 hours multiplied by 3600 is 36,000 seconds of time offset. And you just need to put that information here, GMT offset in seconds. If you are based on New York, your offset time is minus 4 hours. Minus 4 multiplied by 3600. The offset time in seconds is minus 14,400. In the table below, time offset in seconds has been calculated and provided for you. You just need to know what your zone is in the column next to it. Daylight saving setting. Based on different time zones, you might need to configure this setting. And this is where this configuration is located at. If you need to enable or disable this setting, you have to change this value. If you need to set it, you've got to change this to 3600. And if you have to disable it, you can keep it as 0. Next step is configuring your IDE. You just need to come here and search for WRover. Pick WRover kit and select the right port. If you don't know which port it is, just disconnect ESP32. That port should disappear and connect it back. Now you know which port your ESP32 is connected to. In my case, it's COM6. Just press enter and make sure this speed is to 1152 and make sure this speed is selected appropriately. Now click on upload. IDE is going to read the code and upload it to the microcontroller. if you need to verify the code uploaded appropriately, we need to monitor the serial port. This is how our microcontroller sends information to our PC for monitoring and troubleshooting. Just make sure you have the right speed configured like this, and you should be able to see some new lines getting displayed on this window. Don't worry about what these information mean. As long as you can see some changes here, that is what we are after at this stage. Now let's move on to the next step and start assembling electronics. On the PCB board, you can find an area that's called practice area. This area, as the name indicates, it doesn't have a specific functionality and just provided for you to practice here before you begin soldering components. You can sharpen your soldering skills here, and don't worry about which pad you are going to solder in the practice area. All of these nodes are connected to the ground. Just practice here as much as you want, and then we can move to the next step. For the first step, we are going to solder 4 servo motor connectors. You can see the location these connectors are going to be soldered to the PCB board here. These 4 red circles, it shows where they have to be connected and soldered. These are 4 connectors with 90-degree angles with 3 pins. You might have these 4 connectors provided to you individually, or you might have a larger array of this in your kit package, and you just have to break it to the smaller pieces using your wire clipper. Now we are beginning the soldering process. The way that I solder these components, first I try to solder one leg and then make sure on the other side the connector located appropriately, and then I gonna solder the other legs. Here we have all 4 servo motor connectors soldered in place. Next, we move to battery connector. This is a 2-pin 90-degree connector, and it has to be soldered in the area shown in the picture below with a red circle. This one is a tricky one. You just have to keep your finger until the last moment, otherwise the connector might fall off. These components are no longer needed and they are retired, and you don't have to connect or solder anything into these places. Next, we solder high power connector. This is a straight 2-pin connector, and it has to be soldered in the location as shown in the picture below. Next, we move to microcontroller connectors. These are 2 long female type connectors and they have to be soldered in the location as shown in the photo. Please note, on each side there are 2 arrays of holes, and these connectors have to be placed in the arrays of holes closer to the center of the microcontroller. Here again, I'm going to solder 1 pin and make sure the connector is being located appropriately, and then commit to soldering the rest of the pins. In this case, you can see the connector is not placed correctly, so I'm just going to make some changes and make sure it's being placed correctly before I solder the other legs. So now I soldered the first and last leg and it looks good. So now I'm going to place the second connector. In this case, I'm just going to solder 1 leg again and make sure it is placed correctly. Just be careful of these legs, they are too close to each other. And here you can see this one needs major adjustments. Now both look good. Now I'm going to start to solder the remaining legs. First, I'm going to solder every other leg to spread the heat as much as possible. The reason of using microcontroller in this project, the reason of using connectors for your microcontroller is it would make it easier if you need to repurpose your microcontroller in future for your other projects, or if you need to replace your microcontroller if it gets damaged. If you solder the ESP microcontroller to the PCB, it's almost close to impossible to take it out. Since the connectors are very close to each other, time to time you need to clean the tip of your soldering iron. And that's why I'm using soldering iron cleaning sponge. Now is the time to solder resistors. There are two types of resistors in this project, and the way to separate them is using the color coding printed on the resistors. As you can see, in this stage, we are going to solder 22 ohm resistors, and these are two helpful links that you can use to understand how color coding of resistors work. These are the locations that 22 ohm resistors are going to be soldered in. This document shows how you can interpret the color bands on resistors. Above you can see a resistor with 4 bands. The first 3 bands show the resistor value, and the fourth one is going to show the tolerance value. And in the bottom you can see a 5-band resistor. In this case, the 4 first bands are going to be used to determine value of resistor, and the 5th band is going to be used for the tolerance value of the resistor. In this case, we have a 22 ohm resistor. It means the first band is going to be red, the second one is going to be red, and the third one is going to be a multiplier to power of 10, which in this case is going to be black. So the 22 ohm resistor has color coding of red, red, black for a 4-band resistor. This is another tool that you can use to understand the value of your resistor. We are going to pick a 4-band resistor and pick the color of the color bands. As you can see, red, black, it gives us value of 22 ohm resistor. Now let's move on to soldering the resistors in place. Resistors don't have polarities, and you can solder them in place in any direction. Just put the components in and bend the legs. And we are going to use soldering iron to solder them in place and cut the extra connectors from the back. I'm going to cut the extra connectors in the back. Now we have all 22 ohm resistors in place. Now let's move on to 10 kilo ohm resistors. These are the locations that they have to be soldered. As you can see in this table, I provided the color coding for a 4-band resistor and a 5-band resistor. Here we use this tool to translate the color coding. In case of 4-band resistor, it is going to be brown, black, and orange. And if you have a 5-band resistor in your kit, the color coding is going to be brown, black, black, red. These are the 10 kilo ohm resistors. And we are going to solder them into their places. Like before, just put them in place and bend their legs in the back. And we are going to use the soldering iron to solder them. And cut the extra legs from the back. Now we have all resistors soldered in place. In this project, we have two types of capacitors. One type is electrolytic, which they have polarities and they have positive and negative legs. And as you can see in the picture, in most cases, the longer leg is positive and the shorter leg is negative. And most of them, they have a negative band pointing to the negative leg. The other type of capacitors used are ceramic, and they could be soldered in place in any direction. We are going to start to solder 1000 microfarad capacitor, and as you can see, you can find this value printed on the capacitor. You can see the negative band pointing to the negative leg, which is shorter, and longer leg is the positive leg. Put the capacitor in place, put the positive leg into the hole with plus sign. Solder it and cut the extra legs. Then let's move on to 100 microfarad capacitors, and their locations are shown in the picture. You can see the values are printed on the body. Shorter leg is negative and longer leg is positive. And that's the minus sign on the printed on the body pointing to the short leg, which is negative. Long leg goes to the hole with plus sign. And follow the same process for all of them. I start by soldering one leg of each component to avoid overheating the component by soldering iron. Now you can move on to cutting extra legs. Now we move to ceramic capacitors. We have 4.1 microfarad capacitors, and you can use this link to translate the value printed on the capacitor to its microfarad value. You have 104 printed on the capacitor, and as you can see, it translates to 0.1 microfarad. These are the places that these ceramic capacitors are going to be placed. These type of capacitors could be soldered in any direction. They don't have positive or negative legs. Again, I'm going to start by soldering one leg of each component to avoid overheating, and follow the same process for the second leg. Now let's move on to solder LEDs. These are light emitting diodes, and they have negative and positive legs. And there are 3 ways to understand which leg is positive and which leg is negative. Depending on the manufacturer, all 3 signs might exist, or just one of them might exist. The first one is positive leg is longer, negative leg is shorter. If you look inside the LED, the negative leg is longer and has a bend. And in some cases, the LED packaging has a cut on the negative side. These are the places LEDs have to be placed. The positive leg is longer, and if you look inside, the negative leg is longer and has a bend. I'm just having a hard time to focus my camera here. You can see on the PCB print, the print shows a circle with a flat line. That flat line shows the negative side of LED, and that's where the negative leg has to go in. Just put the LED in place and bend the legs at the back. Just solder LEDs and cut the extra legs. Now we are going to put in place the microcontroller unit and connect the power connector. First, I'm going to connect the power connector. It's a USB-C connector, and the red wire goes to the connector side with plus sign. Now we are going to put the microcontroller in place. Just make sure to put the microcontroller correctly. Just note here the connector is longer than the microcontroller, and these holes here are not going to be used. Now you can power the board using a power bank, and you should be able to see LEDs turn on, and you can use this wire and connect these two pins, which causes LEDs to flash. Now we are gonna move to assembling the main body of Clockometer. At the first step, we are going to assemble the front panel. You need these components. And you can identify the eyebrows by the numbers printed at the back of them. The same numbers should be printed on the black front panel as well. You can identify the numbers following this picture. Just fasten the screws using a screwdriver or a power screwdriver. Next, we are going to move to assembly of midsection part A. You need these components with eyebrows of number 2 and 3, and just make sure to put the screws in the right location. There are 2 screw holes close to each other. In this case, we are going to use the bottom screw holes on each side. This is how these components are going to be assembled. Now we move on to part B of middle section. You need eyebrows number 1 and number 4, and you just have to use the long screws to hold them in place. Next, we are going to assemble servo mount assembly. You can use 2 or 4 screws to hold servos in place. I'm just going to use 2. Just make sure the servos are placed correctly in place and their shafts are located as shown in the picture. Servos are going to be used to control seconds, minutes, and hour and midday needles. I'm just going to put a label on them demonstrating which servo is for second needle, for hour needle, for minutes needle, and for midday needle. Because when this part is assembled and merged to the front panel, it's going to be hard to identify from the wires without labels that from which servo they are coming from. This servo is for seconds display. This servo is for minutes display. This one is for hours. And this one is for midday. Now we are going to integrate the servo mount to the front panel assembly. You need these parts, and it's going to be held in place by these two screws. As you can see, if you don't label wires, it would be hard to identify which servo these wires are connected to. Now we are going to integrate the controller board to the clockometer body. You need these components. Use of spacers is optional. In this case, I'm not going to use the spacers. There are multiple holes in the back panel, and you can place the controller board in any of those that you prefer. In this stage, we are going to place the USB power port to its appropriate place and connect it to the controller board. The red wire connects to the connector with plus sign. At this point, we are going to connect the servo motors to the controller board to put the needles in their place. Connect the servo motors and note that the brown wire in this picture should be on the left hand side. The brown wire is ground connection, red is plus, and orange is signal. Please make sure this wire is connected to this jumper. When this wire is connected, the microcontroller sets servo motors into their default location, which is shown in this photo. And when microcontroller sets servo motors into their default locations, LEDs start to flash. Now I put them in place to the default location. Just remove the wire from the jumper. This wire is used for initial setup of Clockometer for us to place the needles to their correct location, and after that point, this wire is no longer needed. I removed the wire from the jumper, and Clockometer now should show the correct time. It connects to the internet first, gets the correct time, and displays it using servo motors. At this stage, we are going to integrate the front and back assemblies. This is a deep hole, so you need a longer screwdriver or an extension. As explained here, this wire sends the needles to their default locations. Now we move to key rest assembly. You need these components, and the key rest assembly is going to be held in place by two screws in these two places. Now your Clockometer assembly is complete. You are a proud owner of fully functional Clockometer. Congratulations. Please don't forget to subscribe and follow us on social media. Thank you.